Okay, so in this video we're going to go through MANOVA and ANOVA. And as you should notice, the Word document is not in the left-hand side, half of the screen. So the thing is, we're not going to go through the theoretical background. I'm going to keep it very practical because, I don't know, statisticians seem to lack creative writing skills. I don't know, because you just read that stuff and a person's not really engaged in the writing. And I'm afraid that if we have to write that, if we have to go through that, all of you are going to fall asleep while you watch this video. And yeah, I know I have read that somewhere that when adults learn, practical application tends to facilitate them much more than theoretical, you know, discussions and all of that. So, and of course, I believe that if a person has applied a certain concept when they read theory afterwards, they'll have background that'll help them to relate to the material that they're reading. So the whole point, we're going to take a very practical approach in this video. So now, MANOVA refers to multiple analysis of variance. Excuse me. Now the whole point, well, one of the main points I thought, no, we should state that the acronym MANOVA refers to multiple analysis of variance is because I've noticed in some articles the authors will use the acronym, whereas in other articles the authors will use the full title or term. So therefore, I thought that, a person might become confused if they look for ANOVA, but they don't know that it refers to analysis of variance. And then just now, while they're reading through the article, they don't see ANOVA and they start to panic or something. So, like I said, MANOVA refers to multiple analysis of variance. ANOVA refers to analysis of variance. So now, in a case of MANOVA, MANOVA will tell us whether a statistically significant difference exists among the subgroups of a variable in terms of the dependent variable. So in this case, the dependent variable is work-home interaction levels. Okay, so if we find a significant p-value, okay, it means that among the subgroups of language that were involved in the study, a statistically significant difference exists in terms of the levels of work-home interaction. Okay? So let's just recap. When will a p-value be statistically significant? If it is equal to or less than 0.05. And I know we've mentioned that in the previous videos, but in this article, the authors have done the courtesy to place an asterisk next to a p-value that is significant. Okay, so now with MANOVA, the first thing that we do is we look for significant p-values. So now our first significant p-value is language. Okay, concerns language. So therefore, as we've said, this significant p-value insists that a significant difference in terms of work-home interaction levels, the outcome variable or dependent variable. Remember, outcome variable and dependent variable are synonymous. Okay, so like we were saying, a significant difference exists among the subgroups of language in terms of the work-home interaction levels. Okay, so let's go to the ANOVA table of language. Okay, so there we go, ANOVA, differences in work-home interaction levels based on language. Okay, so MANOVA indicated that a statistically significant difference exists. Now we want to see where the statistically significant difference exists. Okay, so once again, the first step, we look at the p-values. We want to mark the significant p-values, and we will only look at the cases which have significant p-values. So in terms of language, all of the p-values are significant. So now, as we can see in the left-hand side, under the item column, these terms refer to the different levels of work-home interaction slash homework interaction, and these are hence the different levels of our dependent variable. And at the top over here, these refer to the language groups that were involved in our study. Okay, so now this p-value suggests that a significant difference, and now when I say significant, in this case I'm just referring to statistically significant, because I don't want to murmur the long term each time. So whenever I say significant in this video, I'm referring to statistically significant. Okay, so therefore, as we can see via the p-value, a significant difference exists among these language groups, English, Afrikaans, and Tswana, in terms of the negative work-home interaction that they experience. So now, of course, we want to find out who experiences the highest level of negative work-home interaction. So what we're going to do is we're going to look at these numerical values, okay? English has the highest numerical value. Therefore, the English participants reported to experience the highest level of negative work-home interaction. And on the other hand, Afrikaans has the lowest value. So therefore, in this study, the Afrikaans participants gave reason to believe that they experience the lowest level of negative work-home interaction. Okay, and then Tswana, they were in between in terms of negative work-home interaction and the levels thereof that they experienced. So now if we look at these little sub-comments over here, we can see A, B, and C are attached to the values. So now let's look at the sub-comments, okay? They say if a number is marked with A, it means that that group statistically significantly differs from the group where B is indicated, okay? So A significantly differs from B, okay? So therefore, the level of negative work-home interaction that English people experience significantly differs from the level of negative work-home interaction that the Afrikaans participants experience, okay? And now as we can see, the biggest, well, the largest difference in terms of the numerical values here exists between English and Afrikaans. So therefore, the wider the gap, the more significant it will be. But the statistics program will do the effort to calculate whether a statistical significant difference exists between groups. But in any case, because as we can see over here, in the sub-comment it said that if a number is marked by an A, it means that that group differs significantly from the group where B is indicated. So as we can see, English, the levels of negative work-home interaction that they experience differ significantly from the level that is experienced by Afrikaans and Tswana people, because both of the numbers are marked with B. And then let's look at what the B mark refers to. I can't think of the correct term for these little numbers or marks over there, but in any case, so let's see what the authors are suggesting if one of these numbers are marked by a B, okay? They say B, if a number is marked with B, it differs significantly from the group that is marked with the C. Okay, so Afrikaans differs significantly from Tswana and from English in terms of the negative work-home interaction that they experience. Okay, so we would apply the concepts that we just applied in the first row to the rest of the rows. So, okay, we'll take a look at the second row, positive work-home interaction. Okay, let's take a look at which language group has the highest number once again. Okay, English has the highest number in terms of positive work-home interaction. Therefore, it means that they experience the highest level of positive work-home interaction. So now the lowest value, okay, is Afrikaans again. So therefore, the Afrikaans participants experience the lowest level of positive work-home interaction. That was in the case of the participants of the study. And then Tswana is in between. So therefore, if we go in descending order, the English participants experience the highest levels of positive work-home interaction because they have the highest numerical value in this table, followed by the Tswana participants, and then followed by the Afrikaans participants. Okay, and then we'll go through those, I don't know why I can't think of the right term, but what is meant if a value is marked by A, B, or C. So let's go through that once more. Okay, over here they say that if a value is marked by an A, it means that that group differs statistically significantly from the group where B is indicated. Okay, so there's the A is there, the B is over there. So therefore, English participants differ significantly from the Afrikaans participants in terms of the levels of positive work-home interaction that they experience. Okay, and then if a number is marked with B, it means that it differs significantly from the group where the C is indicated. So let's look at a B. Okay, so Afrikaans differs significantly from Tswana and English in terms of the positive work-home interaction or the levels thereof that they experience. Okay, so therefore, I hope that the discussion of these two rows has basically conveyed the whole concept or point or how we do the ANOVA. Okay, and luckily, well, one of the main reasons why I recorded a video so that you can rewind and revise if you want to. Okay, so let's go back to the MANOVA table. Okay, so we saw that gender is also marked by a statistically significant p-value, which means that statistically significant differences exist among the subgroups of gender in terms of the levels of work-home interaction that they experience. So then we'll go to the ANOVA table for gender to explore the, how those levels differ among the gender groups. And by those levels, I'm referring to the levels of work-home interaction. Okay, so there we go. We saw a significant p-value and for gender under the MANOVA table. So we're going to go to ANOVA. Okay, ANOVA for differences in work-home interaction levels based on gender. Okay, so what is the first step when we look at excuse me, what is the first step when we look at an ANOVA table? It's basically the first step that a person conducts when they look at any statistical table. Well, in most cases, we look at the p-value. Okay, we want to look for a significant p-value. Now, which p-value is significant? Okay, that one. Okay, now which subcategory or level of work-home interaction does it refer to? It refers to negative work-home interaction. Okay, and of course the subgroups of gender, male and female. Okay, so who has the highest numerical value? Okay, the males do. Yes, the males do. So therefore, the males experience higher levels of negative work-home interaction than females do. And the difference thereof is statistically significant because we can see over here, yeah, there are values, but they're basically next to each other, so they're not significant. Okay? So let's look at one more group. Okay, so we'll take the next group that has a significant p-value in the MANOVA table. That is marital status. Okay, so let's go to the ANOVA table for marital status. Okay, ANOVA. Okay, so ANOVA in terms of the differences in work-home interaction levels based on marital status. Okay, so we're going to look for a significant p-value. Okay, now in which row is that? Okay, there our significant p-value is, and it is within the row of positive work-home interaction. And the subcategories or subgroups of marital status refer to married or unmarried. Okay, so now between married and unmarried, which of the two have the highest numerical value? Okay, unmarried. So therefore, in terms of positive work-home interaction, unmarried people tend to experience higher levels thereof than married people. Okay, so that was in the case of this study. They're indicating, as we've said, in other words, unmarried people, according to this study, or in the case of the participants of this study. Now, of course, these conclusions are limited to the participants in this study. They're not being generalized. But in this case, unmarried people experienced higher levels of positive work-home interaction than married people did. Okay, so that's the concept that I've basically, I'm trying to think of the right word, conveyed. And yeah, I trust that if you go through this video a few times and you grasp the concept of what I'm doing, you'll be able to apply it in other MANOVA and ANOVA tables. Okay, so like we say, we go to the MANOVA table, we look for significant p-values. Once we find our significant p-value, we look at which variable it refers to, and then therefore the MANOVA table, if we have such a case, it will say that, for example, a significant difference exists among the subgroups of language in terms of the subgroups or sublevels of our dependent variable, which in this case is work-home interaction levels. Okay, and let me just quickly check something about the partial eta squared over there. Quickly going through my book over here. Okay, partial eta squared. So in the case of MANOVA, Palant says that partial eta squared represents the proportion of variance in the dependent variable that can be explained by the independent variables. So in this case, the independent variable of language and its subgroups can explain 36% of the variance in work-home interaction levels. Okay, and then I know that partial eta squared holds a slightly different meaning in terms of ANOVA. So let me just quickly look at what it refers to in the case of ANOVA. Okay, I'm quickly paging through my book. Okay, so they say in ANOVA, partial eta squared, the numerical values thereof, will indicate, let me just quickly check. It says that the partial eta squared will indicate the effect size. And yeah, I don't think we really need to know that. Just the whole point is, in the case of ANOVA, the significant row that has the highest partial eta squared value explains or has the highest effect size towards the dependent variable, if I'm not mistaken. But the only reason I'm mentioning that is in case Crizal, for example, in a question that relates to ANOVA, she asks you, okay, which sub-level or which level of work-home interaction has the highest effect size. Then you'll look at partial eta squared, and you'll look at the row that has the highest number under that category, and then that will be the level of work-home interaction that has the greatest effect size. Okay, I trust that this video has helped all of you. And yes, let me just quickly scroll to the top of this article so that you can see the article that I was referring to if you want to read through it for yourself. Okay, so yes, I believe that that's all the information that you'll need to gain access, or I'm trying to think, download the article. But all the best of wishes, and good luck.